This video will help you fill out the top flap of section number 4 in your Unit 7 similarity book. Top flap of section 4. The essential question is, what shortcuts can I use to prove that two triangles are similar? Now, we learned last year some shortcuts to proving that two triangles were congruent. And we talked about how to use side, side, side congruent, side, angle, side, angle. We also had hypotenuse, leg. Well, there's some shortcuts to prove that two triangles are similar as well. And here is the first one. It is called angle-angle similarity. Angle-angle similarity. If two angles of one triangle are congruent to two angles of another triangle, then the triangles must be similar. So class, the reason we're calling these shortcuts is because if I asked you to prove that these two triangles are similar, we've already practiced in class. You'd have to match up all three corresponding angles to see that they're congruent, and you have to match up all three corresponding sides to see that they are proportional. If those 6 things are true, you have proved similarity. But now with triangles, I'm showing you that all you have to really prove is that two angles of one triangle are congruent to two angles of the other. If you can prove that, then you know these triangles have to be similar. And that means all the sides are proportional and the third angle is also congruent. So let's take a look at this example. Let's label some of these vertices. I'm going to label this one G. Now that turned black. Let's change that to purple. This is G. Let's make this one H. Let's make this one I. And then for this triangle, I'm going to go ahead and label that as J, K, and L. So there we go. And let's go ahead and see if we can prove these two triangles are similar without going through all of the sides and all three angles. So here's what we can write. Since angle G, you can see that angle G is congruent to angle L. They both have the same angle measure. G and L are congruent. You also see that angle I is congruent to angle J. So I and J match up. We've already proved it, class. Two angles from the first triangle are congruent to two angles of the second triangle. Then we know that triangle. Now remember our similarity statement. We better make sure we put these letters in the right order. G, let's put a similar here. G corresponds to L. That's got to be, you'll put that in the first position. I corresponds to J. So that's going to be in the second position. And the leftover one is H. H corresponds to the leftover angle here, which is K. Remember, the order of these letters is very important. Now, you don't have to put them in this order. If you wrote I, H, G over here, you would have written J, K, L over here. If you put H, I, G over here, you would have put K, J, L over here. As long as you match up, G matches up with L, I matches up with J, H matches up with K, you can put this order whatever you want. But they have to correspond to each other based on their position in the similarity statement. Alright, so those two triangles have been proven to be similar since we know that two corresponding angles are congruent. Okay, and I want you to put a little note here on the bottom of your page so you remember this part, which is very important. Note, G corresponds to L, and I'll just put ditto here, corresponds to J, and H corresponds to K. We also can tell now, class, what sides correspond. We know that GI corresponds to LJ, IH corresponds to JK, and GH corresponds to LK. So there is your similarity or proof of similarity based on two angles. All right, let's go ahead and do an example of this now. Sample of this. Move this over. Are these triangles similar? Let's see if we can use AA similarity to prove this. Well, let's label the vertices first of all so we can know what we're talking about here. So let's pick light blue. And let's label this one, doesn't matter. I'm going to label this one as A, B, C. And let's label this one as D, E, F. D, E, F. All right. So let's take a look. Are these triangles similar? Well, I've got one angle measure that is okay. We've got angle B is, we already verified, that is congruent to angle E. Now we got a problem. Angle C is not congruent to angle D. So your first guess is going to be, oh, you know what? These are not similar because I don't have two angles which are congruent. But class, you need to also compare the third angle to see if that might solve our problem. So remember, to find the measure of angle A, we're going to have to use our knowledge that the angles of a triangle add up to 180 degrees. So let's go ahead and do that. So we're going to find the measure of angle A is equal to 180 minus 52 minus 54, because we're going to subtract these two angles. We're going to end up with 74 degrees. So we just found out this angle measure is 74 degrees. Let's find the measure of angle F. Measure of angle F is 180 minus 74 minus 52, and that equals 54 degrees. So F is 54 degrees. Now class, I'll tell you, I didn't really even have to figure out the measure of angle F, because when you figured out the measure of angle A and that was 74, do you notice that A and D are therefore congruent? That means two angle measures are congruent for these two triangles, and that means we have similar triangles. I just wanted to show you that you could just figure out all the angles. Now you see that actually all three are congruent. But I knew already that angle B and angle E were already congruent. Now I can just pick another pair of angles. I've got also angle A. Angle A is also congruent to an angle, and that is angle D. And now I'm done. One pair of corresponding angles is congruent. The second pair of corresponding angles is congruent. Even though we know the third is as well, that's not necessary. Based on the information that we just found, we can conclude. So, let's not do that in blue. So, triangle ABC is similar to triangle, let's make sure you match it up correct. A matches up with D, B matches up with E, and our leftover letter is F. So triangle ABC must be similar to triangle DEF by the AA theorem. Alright, last example. Let's take a look at the bottom. Which triangle side corresponds to side AC? Now this is where it can get tricky. You don't want to start guessing which is which. Now of course we don't have any letters on this diagram. Let's do this right now so we can figure this out. Let's go ahead and label this as A. You would have had this labeling already on your test or quiz if you had to do this problem. You don't have to make these up. And this is C, is the intersection there, and this is B. If you can see, class, this diagram is two triangles. Which triangle side corresponds to AC? Now, they're not asking us whether the two triangles are similar. We're going to presume, or this question actually should have already told us that these two triangles are similar. Now I want to know which side of this triangle, ECD, matches up with or corresponds to this triangle, ACB. And here's how we do this. First of all, we're going to take a look at something that we know here. Since, the thing we know actually is one angle. Since angle B is congruent to angle E, so take a look at that. They gave us two angles that were congruent, so those two angles correspond. Now look at this, class. You learned this last year. When you have two intersecting lines, these two angles right here, these two angles are a certain type of angle. Do you remember what kind of angle those are? They are vertical angles, and vertical angles are always congruent. And that means that angle C of our one triangle is congruent to angle C of our other triangle. So now we've got two pairs of congruent angles. Oh, therefore we're actually proving that these two triangles are similar. So we can actually make this statement right now. Since we know that's true, then we know triangle, let's get this matched up right. Triangle something is similar to triangle something. Well, B corresponds to E. C corresponds to C. So what's left? We've got B, C, A. So A is left on this triangle. And we've got D, E, C. So E and C have already been noted. We've got D left over. There is your similarity statement. Now once you write your similarity statement, watch how this question answers itself. Take a look. We're looking for the side that corresponds to AC. Well, there's AC right there. It's in the second and third position. That means it corresponds to this side, CD. So our final answer is going to be, let's see if I can write this in blue. So, AC corresponds to CD. Or we can actually say DC. It doesn't matter. If you want to put it in the same order as AC and say DC, you can do that as well. CD and DC are the exact same thing. Now look at our diagram, class, just out of curiosity. Look at those two sides. I'm going to highlight those so you see them. AC is right here. DC is right here. So these two sides are actually the sides that are proportional. Most of us want to say it's going to be AC and EC, but it's not true. When these triangles connect together, there's a reflection going on here and a dilation. So actually AC corresponds to DC. We can then pretty much find out that EC corresponds to BC, and ED, the first and the third position, ED corresponds to BA. So the answer to this question is, based on the rules of similar triangles, we found that AC corresponds to DC. And that's the end of this flat video.